All right, guys, here we go. Another trig lesson, lesson 6. So I'm going to jump right in. It covers a lot of review, beginning with 6.A. It's a review of fractional, or it should be rational. I don't know why I put fractional. I'm going to put, I'll just leave it, sorry. Fractional equations. So again, this is all review from Algebra 2, but it's been a while. So number 1, we're going to go over how to add and subtract rational equations. So for example, 4/7 plus 3 over x plus 2 equals 5/3. Now, there are a couple of ways to do this, but like you could move the 4/7 and create a least common denominator, or I can just find a common denominator from right here. Common denominator, and I'm looking at all 3 denominators, so I'm looking for a common denominator between 7, x plus 2, and 3. So looking at 7 and 3, I know the common denominator is 21. And then I have to include this. It's nothing like these two, so I'm just going to put it in parentheses. Here's my common denominator. Now again, this is one way to do this problem, okay? So I'm going to multiply each fraction by my common denominator. So I'm going to multiply this one by 21, x plus 2, this one by 21, x plus 2, and this fraction by 21, x plus 2. Okay, so here we go. If I ignore all this, for this first one, 21 over 7 is going to be reduced to 3. So I'm now multiplying 3 times 4 times x plus 2. Plus, for this next one, the x plus 2's are going to cancel, and I just have 3 times 21 equals 21 over 3 is 7, right? 21 divided by 3, because there's an invisible. Remember, this is over 1, this is over 1, over 1. So 21 over 3 is 7. Times, I still have the 5 times the x plus 2. And from here, I'm going to simplify. So this is really 12 times x plus 2, which would give me 12x plus 24, plus 3 times 21 would be 63, equals 7 times 5 is 35, and then 35 times x plus 2 would give me 35x plus 70. From there, it's an Algebra 1 problem. You're going to combine like terms and subtract. So I'm going to move this 12x, and I'm going to move the 70. I like to move a bunch of things at once. So on the left, this is gone. 24 plus 63 minus 70, I got 17, equals 35 minus 12x is 23x. Divide by 23, and x equals 17/23. You can leave it. You do not need to make it a decimal. That is probably the fastest way to do that problem. Okay. Next one, I'm going to do a system involving lots of fractions and decimals. So this is a system of equations. So solve 3/7 x plus 2/5 y equals 11. And the next one is 0.03x minus 0.2y equals negative 0.37. So this equation has fractions and decimals in it. And so the easiest way to solve, this is a system of equations. Okay, this is a system of equations. The easiest way is to get rid of our fractions and get rid of our decimals. So in order to get rid of my fractions, I'm going to multiply the entire equation by my LCD. So I'm going to multiply 35 by 3/7. I'm going to multiply 35 to the 2/5 y, and I'm going to multiply 35 to 11. Okay? And I'm going to write that new equation down here. So 35 times 3/7 x, right? This is going to cancel out, and I'm going to be left with 5. So that gives me 15x. 35 times the 2/5, 35 over 5 is 7. So 2 times 7, that leaves me with 14y. But 35 times 11, that gives me 385. Remember, I have to distribute it to all three. To get rid of decimals, so to get rid of fractions, I multiplied by the least common denominator. To get rid of crazy decimals, I multiply by the decimal place. That doesn't sound right, or I should just put place value. I just ripped my notebook. Okay, place value. So for example, I have to look at the longest decimal, and I'm asking myself what value place is this last one? Is that the hundredths, the tenths, or the thousandths? Those two numbers are in the hundredths place. So to get rid of them, I multiply by 100. So I'm going to multiply by 100. That's another way of saying I'm going to move the decimal 2 places. You can use your calculator. I'm going to distribute this all the way across. And I can't believe I ripped my paper. And I'm going to write the answer down below. So 100 times 0.03x is just 3x. Minus 100 times 0.2 is 20y. Equals negative 37. So each of these I moved the decimal 2 times. Now I'm going to solve this system. So in order to solve a system, I'm trying to create opposite coefficients. So in order to make this opposite, I'm going to multiply this by negative 5, because that will produce a negative 15x. So this 15x and a negative 15x will eliminate x. So I'm going to distribute that. That gives me negative 15x plus 5 times 20 is 100y equals, and that I'd have to multiply out. I believe I got 185. So I'm now going to add these two together, right, because my x's are opposite. So 15x minus 15x eliminates. 14y and 100y make 114y. 385 plus 185, I got 570. Divide, and y equals 5. Okay, from there should be reviewed to find y. You would plug it into any equation. It doesn't matter which one you plug it into. I'm going to plug it into the bottom one. So 3x minus 20 times 5 equals negative 37. So 3x minus 100. So I would add 100. That gives me 63. Divide by 3, and x equals 21. So there is my answer. You could also write your answer as a coordinate pair, but that is fine. Okay? Okay, so that's 6.A. 6.B is a review of radical equations and how to solve them. So we're just going to jump right in. We're going to review a problem that has radical equations. So for example, solve the cube root of x minus 5 minus 2 equals 2. Now again, these are all review from Algebra 2, so it's important we go over it because it will show up in your homework. So first thing we're gonna do is get this guy by itself. So you would add 2 to the other side. So the cube root of x minus 5 equals 4. Right? I added 2 to both sides. To get rid of the cubed root, I would cube it. And so I'm left with x minus 5 equals 4 to the third. So in your calculator, you would enter 4 to the third. And I got 64. And then I would add 5, so x equals 69. Okay. Next one. All right, so we are going to solve the square root of s minus 48 plus s equals 8. Sorry, square root of s. And you know what, that s, I'm going to change that to an x because it looks so much, s's look so much like 5's. Alright, so in a problem like this where you have more than one radical, you're going to need to get it so that there is one radical on each side of the equal sign. So I can only have one here and one on this side. So I'm going to subtract the root of x. And so my problem is now x minus 48 equals 8 minus the square root of x. Now to get rid of this square root, I'm simply going to square both sides. So on the left, these cancel, and I'm left with x minus 48. And on the right, I have to actually distribute 8 minus the square root of x times 8 minus the square root of x. So the left stays the same. I'm going to distribute the right. I should get 64 minus 8 root x minus 8 root x plus x. Now that's because when I multiply a negative times a negative, I get a positive. And remember, the square root of x times the square root of x is just x, that shortcut. The square root of 5 times the square root of 5 is just 5. From here, I'm going to combine like terms. And I'm going to get all my x's on one side, everything else on the other. So I'm actually going to move him. I'm going to move 64. And so the x's zero out. 48 and 64 make negative 112. I'm going to combine these. These are like terms. And that gives me negative 16 root x. Now from here, easy peasy, I'm going to divide by negative 16. And I get these, and I'm going to write what I have over here. The square root of x equals negative 112 divided by negative 16, and I got 7. And then to get rid of the square root, I would simply square it. So x equals 49. Beautiful, right? I know. All right, last but not least is 6-point C. This is also review. Systems of 3 equations. Now, the only method you would want to use to solve these is elimination. And so here is an example of one. Number 5, we're going to solve 2x plus 2y minus z equals 14, and 3x plus 3y plus c equals 16, and x minus 2y equals 0. Now, I'll give you kind of an easier one. Notice that this last equation is missing z. So I'm going to eliminate z in the top two. And I also notice, such a blessing in disguise, that these are already opposite. So I'm just going to add these equations together. So I'm going to find their sum. So 3x plus 2x is 5x plus 5y. The z's cancel, and 14 plus 16 is 30. Okay? So I'm going to rewrite what I have here. I have 5x plus 5y equals 30, and I have x minus 2y equals 0. The easiest to go from there is there's an invisible 1 here, and I'm going to multiply this bottom one by a negative 5. And that gives me negative 5x plus 10y equals 0, and then I'm going to add these two together. I should have wrote that, add, and now I'm adding these. So that gives me 15y equals 30, so y equals 2. From there, we're substituting it in. So x minus 2 times 2 equals 0. So that's a negative 4. So x equals 4, right? I would add 4 to the other side. Last is z. So I know that x is 4. I know that y is 2. I'm substituting into the top equation. So I have 8 plus 4. So I'm going to subtract 12 from both sides. So negative z equals 2. So z equals a negative 2. And so those are all 3. So that's a review. For section 6, for homework, you can skip numbers 14, called, 14, 21 through 23, and I don't know if I skipped any others. You might be tortured with the rest. Well, ladies and gentlemen, should I take off one more for you? Nah, I'm going to leave it. Thank you.